Welcome to Ask and Learn.
So the fire hose problem, in this case, in urban areas, so we have a fire hose. It is able to throw water here to a height of 33 meters. The water leaves the hose at ground level at a circular stream 3 centimeters in diameter. So here the stream is 3 centimeters in diameter. So it says what power is needed to create the stream of water. And the density of water is 10 to the power of 3 kilograms per cubic meter. So that's the question. Now we can find out this by the energy conservation. The total energy at the ground level is equals to the energy at the top. Now energy at the ground level is equal to half mv ground square, which should be equals to total energy at top is equals to my top. So we can calculate V ground as equal to square root of 2 GY top should be equals to 2 times 9.8 times the height, which is 33 meters. That should give you 25.43 meters per second. So which means that the water should come out at this at 25.43 meters per second. Now the area of the water stream times the velocity actually gives the volume flow rate. Now if that is multiplied by density, let's say if we multiply the area by the velocity and by the density, which is rho, so area unit is square meters, velocity is meters per second, and density is kilograms per cubic meter. If you solve that, you will just simply get kilograms per second, and that is exactly what is needed. Another way to think is that AVP is the mass that flows out of the hose per second. So this is basically the mass per second. It takes a minimum force of this times G to lift that mass. So the work done per second to lift that mass to a height of Y top will be equals to the work done will be equals to A V rho G Y top. So once again, AVP, AV rho is the mass that flows out of the hose per second. We have just seen that. And it takes a minimum force of mg, which is, this is mass times g, to lift that mass. So the work will be equals to mgh, which is mg y top. So this is basically the power required. So I'll solve it here. So power required is equals to A V rho g times y top, because that will give you the unit, of kilogram per second. If you solve that by plugging in the value of area, so right here, solve it, is equals to power is equals to pi area 1.5 times 10 to the power of negative 2 meter, converting centimeters to meters squared, velocity 25.43 meters per second, the density is 1 times 10 to the power 3 kilograms per cubic meter times 9.8 times 33. So if you solve that, you will get 5813 watts as the power required.